Hello everyone. For this tutorial video, I'd like to prove that you can find the average value of a function using integrals. We first start by dividing the interval from a to b into rectangles who have a width of b minus a over a number of rectangles, like with the definite integral. We know from statistics that the literal definition of the average is object 1 of set plus object 2 of set plus object 3 of set plus object 4 of set, etc., divided by number of objects in set in total. So it follows, because we are asking for an average function, that we plug in this formula, where the numerator is function at point 2 plus function at point 2 plus function at point 3, etc., and each point is in the intervals or rectangles. We can see, with some rearrangement of the change in x formula, that the number of rectangles can be found by b minus a over change in x. So we plug this in to the average function. We see we can break up the fraction so that we are multiplying the sum of all the functions in each interval by the length of each interval, and 1 over b minus a. We see that the sum of the functions can be condensed using summation notation, and we see if we take the limit as n approaches infinity of the sum, or the number of terms in the sum. This is the literal definition of the definite integral. So in conclusion, the average function from point A to point B is 1 over b minus a times the integral over this range. Now that we have seen why we can use integrals to figure out average function values, we can move on to the more common type of integral application, which is finding the area and volume of complex shapes. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.